Hello, college algebra. I just wanted to help you a little bit with a couple of pieces of the matrix homework. So when you start your homework, one of the things that you want to realize is that when you have a matrix, it's always row and then column by the size. So we have two rows, so that's why it's the 2 is first, and 1, 2, 3 columns, so that's why it's the 3 is second. We have 2 rows and 3 columns, so that makes it a 2 by 3 matrix. This is a matrix of no special type. If it was a square, it would have what? It would have the same exact rows and columns, 2 by 2, 3 by 3. A column matrix is made up of one column and multiple rows. A row matrix has one row and multiple columns. The additive inverse of the matrix. So if I add -5 plus, here's my 5, I get 0. So -3 plus what equals 0? Well, the inverse of a -3 is a +3. The additive inverse of a +7 is a -7. So in order to add two matrices, we need to have the same number of rows and the same number of columns. And we are going to add exactly where they come from. So I have 4 plus 7 equals 11. So this is a what? A 2 by 4 matrix, a 2 by 4 matrix. My resulting matrix has to be that 2 by 4. That's why the 7 plus 4 equals 11. Next I have 4 plus 0 equals 4. 9 plus a -11 is a -2. Subtraction worked the same way. So if I have 2 minus a -6 minus a negative, 2 plus 6 is 8. I have a 7 minus a -1. 7 plus 1 is also 8. Notice you need to have, I have a 3 by 2, a 3 by 2, and my resulting matrix, a 3 by 2. So if I have a number out front, this is the same as doing distributive property. So this is saying to multiply everyone in my matrix A by a -4. -4 times a +5 is a -20. -4 times a +2 is a -8. So this wants you to set up a matrix. When a ticket holder fails to attend, sports teams lose money and those fans have spent on refreshments, souvenirs, etc. Percentage of fans who don't show up is 15% in basketball and hockey, 14% in football, and 20% in baseball. The lost revenue for a fan is $18.02 in basketball, $18.31 in hockey, $19.05 in football, and $15.65 in baseball. Total annual loss is $20.2 million in basketball, $39.9 million in hockey, $50.6 million in football, and $94.2 million in baseball. Express it in matrix form. So what you need to do on a problem like this is you want to select your rows. So the rows are going to be what? Percent of no-shows and then the lost revenue per fan and lost annual revenue. The columns are going to be sports, basketball, hockey, football, and baseball. And almost think about a multiplication table where if you had to do like a 1 times 1, you look them up and you come together. It's the same thing. Percentage of no-shows in basketball is 15. 15 is the percentage of no-shows in basketball. Well, my next is hockey as well. Percentage of no-shows in hockey is also 15. In football, percentage of no-shows, football is going to be 14. Same thing is going to happen to lost revenue. Lost revenue for a fan is $18.02 in basketball. Lost revenue for a fan in basketball, $18.02. The chapter 6 homework gets pretty complicated pretty quickly here. So A times X equals B. Well, we know that the opposite of multiplying X by A is dividing it. However, with matrices, we can't divide matrices, so we have to take the inverse. Not the additive inverse, but the inverse. So first thing I need to do is if I do the inverse of A times A, I'm going to get 1, which means I need to do the inverse of A times B. So I am going to come into my calculator, and I have a 1, -5, 6, and 2. So I have my matrix. I'm going to click on Find the Inverse. And so now I'm going to find the inverse. And when I do that, what's going to happen is it is going to tell me that the inverse of this is this right here. So what I'm going to do is insert this into A. So now up here, that's my inverse. I need to multiply that by B, which is negative 21, negative 23, negative 21, and negative 23. I now want to multiply these matrices together. A times B is this guy right here. And when I come down below, my answer is 3, negative 4. 3, negative 4. And so what I needed to do was the first thing was I wanted to solve for x. So I needed to do the inverse of A times B. But we had to make sure we realized it was not the additive inverse. We can use this calculator here to find the inverse after we put it in. We can then insert into A and then type in your B matrix and then click the multiplication. So this one's telling me to use the inverse coefficient matrix to solve the system of equations. I'm just going to show you how to solve any system of equations. So what we have here is they're looking for x, y, and z. So what we can do is we can imagine that there's no x's on this first piece right here. The x is going to go right above the top. There's no y's. The y goes right above the top. The z's, they go right above the top. And any of my signs in between, that just tells me if the number is positive or negative. And these equal signs are going to make a fourth column. So what we're going to have is I am going to end up with a 1, 2, 3 rows and 1, 2, 3, 4 columns. We're going to show you 3 and 4. I'm going to hit submit. Now I have to type in my matrix. So as I type in my matrix, I put you on hold, and now I'm going to hit submit. And now what I'm going to do is I'm going to come down here, and you see where it says reduced row echelon form? I'm going to click on that. You're going to see all of this stuff. This is showing you step by step how to do the reduced row echelon form. The most important thing is down here where I get an identity matrix. An identity matrix is where I have the 1, 0, 0, 0, 1, 0, 0, 0, 1. So my square matrix here has ones in the diagonals and zeros everywhere else. So remember, this was our x column. Well, x equals a negative 62. This was my y column. Y is 53 and z is a negative 9. So you see my answer here, x, y, z, negative 62, 53, and negative 9. I'm going to include these calculators in my my announcement. So good luck this week, and please be sure, use your Help Me Solve This, use your tutors, use me, use the videos, lots of resources out there. Please, if you're struggling, you need to get the tutors sooner rather than later. Have a good day.